Imagine you are looking out your living room window. There's a massive, heavy rainstorm falling over your neighborhood. The streets are flooding, the trees are completely soaked, and water is just cascading down the glass. It feels like the entire world is drenched. In that exact moment, the absolute last thing you would ever worry about is a fire breaking out. It feels like a total paradox, right? How could a fire possibly start, let alone survive, in the middle of a torrential downpour? Well, as we're going to see in today's explainer, Mother Nature has a few incredible tricks up her sleeve. So, we have to ask this highly counterintuitive question. Can fire really start during rain? The short answer is a resounding yes. It all comes down to a very simple yet dangerous reality. Rain falls from the sky, sure, but fire can begin in places where that rain simply cannot reach. We constantly think of rain as the ultimate fire extinguisher, but storms actually bring incredibly powerful hidden ignition sources that completely bypass the wet weather outside. Okay, let's dive into this. First, we'll look at the rain and fire paradox, then the science of combustion. Next up, lightning's extreme heat, followed by hidden fuels and oxygen. And finally, we'll wrap up with some crucial storm and fire safety. Section 1. The Rain and Fire Paradox. Look, it is entirely true that rain helps fight fire, but it only reduces the risk. It absolutely does not erase it. See, rain extinguishes fire by cooling surfaces down, but that mechanism only works on surfaces the water actually touches. If a storm rolls in, it cools your roof, your lawn, and the streets perfectly, but inside your walls, up in your attic, or deep beneath a thick forest canopy, it's completely dry. All the danger is still right there, just waiting for a spark. Section 2. The Science of Combustion. If we look at the National Fire Protection Association's fire triangle, combustion relies equally on three things: heat, fuel, and oxygen. Take one away, and the fire dies. Now, a rainstorm removes heat from exposed flames, but it doesn't eliminate all fuel. It certainly doesn't remove the oxygen, and it actually brings its own hidden ignition sources. Two sides of that triangle are completely untouched by the rain. Now, what's really interesting about this is when we look back at Antoine Lavoisier's historical work, he's the one who established oxygen's absolute non-negotiable role in combustion. Well, during a storm, the highly turbulent atmosphere acts just like a giant bellows. It's constantly moving Lavoisier's oxygen around, providing a steady, rich supply to any potential spark. Just picture it for a second. A fire out in the open, rain hits it directly, removes the heat, and puts it out. Easy. But under a roof, your attic insulation and dry wood are completely shielded. If a spark happens up there, the dry wood gives it fuel, ambient air gives it oxygen, and the rain is completely locked out. The fire triangle is perfectly intact, literally right over your head, while it's pouring rain outside. Section 3. Lightning's extreme heat. So where do these hidden sparks come from? Lightning. It is undeniably one of the biggest reasons fires begin during storms. It's a giant electrical discharge packing a massive punch of heat. And here is a frankly terrifying fact from the National Weather Service. Lightning can often strike miles away from the main storm core. That means it can hit an area entirely outside the wetting rain footprint. It's striking and sparking fires where the rain hasn't even started falling yet. And when we say lightning supplies extreme heat, we are not exaggerating. According to the National Weather Service, a lightning strike can heat the surrounding air to around 50,000 degrees Fahrenheit. Guys, that is far hotter than the surface of the sun. When something that unimaginably hot strikes a dry tree or house roof, any moisture in the air doesn't stand a chance. It is immediate, explosive ignition. We really can't talk about the immense power of lightning without tipping our hats to Benjamin Franklin. His historical work helped demonstrate the true electrical nature of lightning. Franklin showed us that lightning isn't just some magical fire from the sky. It is raw electrical energy. And because it's electrical, it doesn't just hit a roof and politely stay there. It aggressively seeks a path to the ground, which leads us to a very dangerous modern problem. Because lightning is electricity, when it strikes a home, it naturally follows the internal wiring. This immense energy surges right through the wires hidden inside your walls, and that massive overload causes your electrical panel or a wall socket to violently spark inside the wall cavity. It literally transforms an external weather event into a hidden indoor electrical fire. And the rain outside, it's completely irrelevant to the sparking wires trapped inside your dry drywall. Section 4. Hidden fuels and oxygen. As we've established, indoor environments are perfect safe havens for fires to start because the fuel is perfectly dry. But this isn't just about houses. The National Weather Service notes that even heavy, measurable rain often won't penetrate thick vegetation. A dense forest canopy can act exactly like a giant umbrella. Underneath that canopy, Deep layers of dry fuel beds and pine needles remain bone dry, providing the absolute perfect protected environment for a lightning-sparked fire to catch and spread. And let's not forget what else always accompanies a heavy rainstorm: the wind. Severe storms generate incredibly strong, erratic winds. If lightning sparks a fire beneath a dry canopy or inside a damaged structure, those winds act as a massive, continuous supply of oxygen. They fan the flames and relentlessly push sparks and embers to new, dry locations. The wind basically supercharges the combustion process, completely overriding any dampening effect from the localized rain. And this brilliantly illustrates a dangerous psychological trap. Wet outside does not mean safe inside. We hear the rain, we feel sheltered, and we just naturally drop our guard. But inside, you are surrounded by dry materials, potentially compromised electrical faults, or even everyday hazards like cooking equipment and flammable liquids that can easily trigger a fire if a storm knocks out a transformer or surges your grid. Section 5. Storm and Fire Safety. First things first, the National Weather Service has clear protocols for thunderstorms. The golden rule is simple: when thunder roars, go indoors. But once you're inside, you have to disconnect from the paths that lightning takes. Avoid electrical equipment. Don't be the ground for a power surge. Avoid plumbing because metal pipes and water conduct electricity beautifully. Stay off corded phones and keep away from windows indoors. You want to fully isolate yourself from the perimeter and the wiring of your home. But what if a fire does start inside your home during the storm? The U.S. Fire Administration warns that you must use special caution because not all indoor fires can be fought with water. In fact, water can make them much, much worse. If a power surge starts an electrical fire, throwing water on it can electrocute you. If you're cooking during a storm and a grease fire starts, throwing water on it will cause a violent explosion of flaming oil. Instead, simply slide a lid or baking sheet right over the pan to instantly cut off the oxygen. It all comes back to understanding the full picture here. Rain may fight fire from the outside, but lightning, electricity, and hidden fuel can start fire from the inside. We have to respect the intense physics of a storm and recognize that our dry sanctuaries can quickly turn into fuel if we aren't prepared. So next time you hear the thunder roll and the rain start to pour, ask yourself, is your home truly safe from the storm or just sheltered from the water? Stay curious, stay safe, and I'll catch you in the next explainer.